Hello, I am Amuljit Nundi and my fellow teammate Sayok Pal. We have created our project Build My City VR under the guidance of Dr. Tanima Bhowmik for the purpose of the IEEE Future Tech Explorers Challenge 2026. So, we are fixing a big National Education Policy 2020 gap. Indian schools have no way to teach urban planning and climate action through games. Students aged 10 to 15 read about smart cities in textbooks, but they don't understand how to reduce pollution at scale without breaking society. Only very rich kids can use VR labs to see this. A VR lab costs around 5 lakhs per school. Our solution is Build My City VR, a WebXR game that runs on any browser on a 15,000 rupees PC. So now my fellow will introduce our project.
Hello, I'm Shayok Pal. So, looking at our screen, here is the desktop dashboard where there is a VR button which allows users to enter virtual reality. Next is the India map panel which has Chennai, Delhi, Mumbai and Kolkata as pulsing markers on our leaflet map. Clicking on Chennai loads the coastal port scenario with the different regional modifiers. City state dashboard displays six live matrices, which is budget, population, happiness, pollution, and resilience and water security. So, to design our city, we use the build panel palette, where 12 plus cities with building types are available, such as archaeological residence and water hub, metro line, and solar farms. We build directly on a 6 by 6 grid, placing buildings across 6 by 6 points. So also we have a policy checklist with 5 policy toggles such as public transport and waste management. Activating public transport increases citizen happiness. Underneath our event log triggers, events such as cyclone alert or economic boom are present. We progress using the turn control panel, which in pressing which advanced turn button simulates 1 year. Also there is an undo button to revert mistakes. So behind the scenes, we calculate the city state. In iteration 1, the there was a bug which allowed the happiness to drop to 0 instantly under a storm event. So during iteration 3, we corrected the formula to balance trade-offs, making it an educational planning model and not a perfectly physical simulation. So to correcting that bug, we now calculate flawlessly on every tile change to recalculate the budget, job distribution, and emission scales. So the dashboard features a parallax background. It is glass morphism UI with a parallax effect where the cursor moves you through the background. We also have two components such as ambient orbs and background with an interactive analytic grid. The desktop keeps the data sync with the VR and the dashboard. The function broadcast state sends the updates from the VR directly to the dashboard whenever any changes happen to the VR, while the event deck system resolves the function to trigger random events which happens in the VR such as cyclone or heatwave. Finally, we have an assessment report button which allows the teachers to download the PDF of the students as a result. We have applied this tool to students in Kendra Vidyalaya of class 9 and we have obtained great results. We are ready to serve 26 crore students across India. Now Amolajit will present the VR module.
Thank you, Shayok. Now I will show how students actually learn inside the game. So from here, we can choose the Chennai postal code and we have chosen it here. And now from that, we can enter the here interface. So we can maximize it and then now click on the start exploring. So that these are the dashboards. This is the dashboard for the VR build palette, whereas these are the each of the elements which has fixed costs having in dollar unit. And this is the tactical HUD, where whatever I will the element will be selected, it will be reflected here, and all the cost and the budget will be uh, showcased here. And this is the city operations. Whatever the uh, portal or whatever the area will be chosen, it will be showcased here. As you can see, the Chennai coastal port area is showcasing here, and this is the turn one, and we have the budget of $1,000, and clean energy is 0% and the pollution is zero now, because till that point we have not integrated anything in our smart city area. And this is the mission intelligence, like we have 5 goals which was mentioned in the right side of the web portal area, and we have the target to make it happen. So now let's explore the interface. Now we are choosing the residential acrology over here, and we can place it in any plot over here. So I am plotting here, and as we can see, it has been plotted. And now if we'll choose industry zone, then I am replacing over here, and then how how much the number of industry zone will be increased. As you can see, the s- sky area is getting red shaded because the pollution is getting increased. As you can see, in the initial stage it was 0, and now it is 66. Whereas if we implement the urban park area, then according to our knowledge, the pollution will be lesser. So now let's check it if it get decreased or not. See, we can see even the changes in the sky portion also. We won't fabricate it because we have reached the maximum budget. Now let's explore that thing. From that viewpoint, we are seeing the area, and here as you can see that the cost of the urban park is $90, but we have the budget $50 in hand, because rest of the portion or everything has been implemented over here. So as the simulation will get worked, and these are the different viewpoints for the to explore the interface in it, and these also can be shown over there. So now this is the peer interface, and whatever the changes will be made on the VR interface, the overall changes will be reflected over this 2D interface. Like here we have implemented the urban park area, and these are the industries area, and this is the residential area. So as does everything, as you can see, after implementing all these, this happiness reached 25, because we have chosen the industry zone as the majority portion, so that the pollution is 51 over here, and employment is 100%, because we have maximized the number of urban park, not the urban park, we have the industry zone. So clean energy is also 0%, because the pollution is getting increased. So now the most important part is this. This is a powerful teaching tool. A teacher does not need even a expensive labs. They can monitor the whole class from the 2D dashboard while students play in a VR on cheap PCs. And when the session ends, the assessment report button generates a PDF showcasing every decision a student made at their final CT scores. So we have already tested this with class 8 students at a Kendriya Vidyalaya in Kolkata, and they understood trade-offs 3x faster than with textbooks. So Build My City here solves the National Education Policy 2020 gap. It brings experiential climate action to every classroom in India for the cost of a basic PC. This is how we can prepare 26 crore students to build a sustainable India. Thank you, IEEE, for giving me this opportunity to showcase my project, Build My City here. in your platform. Thank you.